In this last lesson, we're having a look at how to write circles in expanded form. There's a very specific format for expanded form. X squared and y squared always come first, then the x term, the y term, then the constant term, and it's always set equal to 0. Other than that, all we're doing really is expanding, and we're using the technique of completing the square. So you might need to go and do a bit of revision from the polynomials chapter on how to complete the square. Let's go through example 14.1. Write in expanded form the equation of the circle with the centre -2, 3 and radius of 5 units. So the first thing that we do is write the equation, which is going to be x plus 2 all squared plus y minus 3 all squared equals 5 squared. We need to expand. So we're going to have x squared plus 4x plus 4 using perfect squares expansion plus y squared minus 6x plus 9 also using perfect squares expansion equals 25. From there, we just collect everything into the correct order. X squared plus y squared always comes first. Oops, I've written x there and I should have written y. Plus 4x minus 6y, so we've accounted for x squared, y squared, 4x minus 6y. Then we've got plus 4, plus 9, and we're going to have to subtract 25 from both sides, aren't we? So it's actually going to be 13 minus 25, so that's minus 12 equals 0. And that's it. It should be pretty obvious to you that, one of the advantages of center radius form is that you can read the center and the radius off it. When it's in expanded form, you can't read any information directly. It doesn't tell you anything about the center or the radius directly. So what we need to do is be able to convert it from expanded form back into center radius form, and this is where completing the square comes in. So having a look at this one, we've got x squared plus y squared minus 8x plus 10y minus 14 equals 0. So the first thing we do is we've got to rewrite the equation so that we can complete the square for both x and y. So the first one will be x squared minus 8x plus something minus the same thing plus y squared plus 10y plus something minus the same thing. And I'm going to pop this minus 14 over onto the other side of the bracket, other side of the equals rather. So that's going to be equal to 14. Now, what's the somethings that we add in and take out? Well, we halve the x term and square it. So 8 halved is 4 squared. We add that in, we take it straight out. With this one here, 10 halved is 5 squared. We add it in, we take it out. From there, we can factorize this part and this part using perfect squares factorization. So this is going to give us x minus 4 all squared plus y plus 5 all squared. I haven't done anything with the minus 4 squared, and I haven't done anything with the minus 5 squared, and that's still 14. So from there, all that's left is to collect our constants over on the right-hand side. So it's going to be x minus 4 all squared plus y plus 5 all squared equals 55. So then we can read off the center. The center is at 4, -5, and the radius is the square root of 55. Bearing in mind that this term is our r squared term, so our r must be the square root of 55. Be very, very careful with that. Last example, 14.3, explain why x squared plus y squared minus 5x plus 3y plus 18 equals 0 is not the equation of a circle. So to do that, we need to complete the square on x and y and turn it into the equation of a circle and see what the problem is. And we're going to have a look at that in the next video.